Anyway, at least you can read now. Let's continue. The process, remember now, process and the processor, there's different. Last time I explained the spelling. Now, process spelling is CESSES. Like here you can see processors. And sometimes we put OR here, then it will referring to the hardware CPU. Now, if it is SSES, this is not hardware. This is something to do with your operating system. Now, you know operating system is a software program, right? Therefore, process we talk here is a software, right? Last time I explained what process is. Can anyone remember? Process basically is a program in execution. Okay? So we call it process. Now, in operating system, we have to handle so many different processors. That means programs in execution, there can be hundreds of them. Right? So today we are going to learn about describe different process models and list different process creation methods and also termination. Now you can see two terms, creation and terminate. So what will happen if you create and not terminate? They will remain forever eating up memory and other resources. So whenever we finish something, we have to terminate it. So first we will see these things. Okay. Now process creation and termination is very important for operating systems. So again, you can see the definition. Process is a program in execution. Therefore, it is an instance of a program running on a computer. Now, your computer, there can be so many programs, but when it is in execution, we call it a process. So it is one instance of the program. If your program is saved on, for example, hard disk, then we do not call it a process because it is just keeping hard disk, not in the execution mode. But when you load into memory, when we want to execute it, then it's a different instance of a program, what we call a process. Okay. So each process associates. So what do you have in a process? Its own code, data, and resources allocated to it. So you should know if somebody asks what's the process in operating system, you should be able to describe it. Okay. So this maybe if you see last year paper, you can see a question from process, right? So you should know how to define a process. What is process and what a process have? It's on code, data, and resources allocated to it. And so in order to get an idea about the processors, we will discuss how a process will be created and terminated within a computer system. So that's what we are going to talk about. When we talk about process creation, there are 4 types of events will lead to process creation. So we'll see one by one. Okay. First one is that this system initialization. For example, when you boot up, when you power on your computer, when you power on your computer, I'm trying to open a chat also. Uh, so hope by now you have downloaded your the lecture notes. You can you can upload it to your WhatsApp group, no? I hope you are doing that. Now, if you have any questions, just ask. Huh? No, right. So that the system initialization stage. When an operating system is booting, several processes will be created. These processes can be foreground or background processes. Foreground means we can see them on the screen. Sometimes background process we can't directly see them. Foreground process are the process which interact with the user. Okay, to interact with the user, it should appear somewhere in the screen and perform work for them. But background processes will not associate with the particular user. Instead, they have some specific function. Now, for example, accepting incoming email can be a background process. Right? So your email box is working. When you open it down, it is receiving incoming. So it's a background process. Okay. So how can you see the existing processes in your computer? If you go to Task Manager, for example, if you press Control or Delete once, twice, don't press twice, the or it will reboot your system. But then if you press once, you can go to Task Manager and see there are a list of processes, right? So those programs running at the moment. So some of them are foreground where you can see interacting with user. Some of the programs they are running background. Okay. So 2 keywords, foreground or background. So while if you have notes, you can highlight those things while I'm teaching. So now can you see the full screen of the notes, or is it covered? Can you increase the size? Is it visible or text? You can see, no? So you can highlight those keywords, foreground, background. Unfortunately, I cannot highlight here. Let me see. Now you can see, no? Right? Can you see the highlighting on your shared screen? Can you see it? Can or not? Yes or no?
Yes, sir, we can see the highlights.
Someone should answer, huh? Otherwise I don't know. Okay, find different. Can you see a note here? Not appearing. Is it visible?
Yes, sir, yes.
Okay, I'm just testing. Huh? So there's a possibility of typing as well. Anyway, okay, right. Good. Uh, so now it is clear, no? Foreground and background process at the initial initialization stage. Then the second, now second types of process creation. First type at the initial stage, initialization, process can boot up. Second type is request of the running process. So processors can be created by a request from a running process. That means when you run one application, it can ask to start another process. Okay. For example, a running process may issue process creation. There is a system call to create a child process. I think last time I mentioned about parent process and child process. So the next process created by one process is known as a child process, children, right? The initial process is the parent. So system calls to create a child process. And the parent and child have the same memory image. This is important, okay? So parent and child have the same memory image, same environment strings and same open files. So they are sharing the same thing, parent and child process. Okay. So we have learned different operating systems such as Unix and Windows are the two main different types. So different operating systems, they have different commands to start or create process. Now Unix, they use the command called for, F-O-R-K. System call is used to create a new process, right? And execve, system call is used to execute the program. So you have to first create a process, then execute it. Okay. But in Windows, single in32 function called create process. So Windows commands are very user friendly. Command itself, you know what it is. So command is create process. In Unix, you have to remember what it is. That's the difficulty with Unix. But here, part of it is the exe, execute. Yeah? But other things, you have to remember what it is. But Windows became popular because you don't have to remember anything. It is self-explanatory, like create process, it is the command. And use both process creation and loading. Correct program into new process. So in Windows operating system, they've been integrated the two things. But Unix, you have to give two commands for this, right? Create a new process and to load it, you have to give this execute command. Okay, so these are example codes. third type. User request to create a new process. The process request, right? Running process request to create another process. Now, user also, we can request to create a new process. For example, when we click a new button or something, we are starting a new process. So it's a user request. Okay? So if a user requests some job from the computer system, in order to achieve that, the operating system will create new processes. For example, in the interactive systems, like for example, when you play a game, computer game, so you can start new things, right? So users can start programs by either by typing a command or clicking an icon using mouse. Now I am using the mouse to click certain things. Right? So even this highlighting thing, I initiate it is a user request. Okay. So that's the third type of creating a new process. And then the fourth one is initiation of a batch job. So can you remember this batch processing term I have introduced when talking about large machines, huge machines like mainframes and so on, like banks, insurance companies, and so on. They have a batch system. Batch system means uh, maybe one batch, maybe 100 commands for different purposes. So you put one batch, one whole batch, like overnight processing, you can use it without user interaction. Automatically, it can perform. Right? So user submits batch jobs to the system, not one by one, but collection of jobs. That's why batch. But you are also your batch. Don't say badge. Huh? Badge is something you are wearing. So when you say our batch, batch, huh? B-A-T-C-H, ch, no, not j. Okay. So batch is a collection or combination. So collection of number of students for the batch. Like the number of jobs, similar jobs for the batch, known as batch. Okay. So when you're talking, very often if you go outside and talk to someone, if you say badge, they definitely know if you don't know English at all. So try to practice this pronunciation. BATC batch is the batch, like 2019 batch. You have to use this term. Okay. So we have noted the students very often they use the other term. Uh, if you type BAD, this is not the your group. Okay. There is something like army personnel, scouts, they wear and their uniforms, badge. But we are a batch. Okay. Don't make that mistake. Uh, right. So number of jobs we use as batch processing. Okay. Right. So if resources are available, the operating system creates a new process and runs the next job from the input queue. So it's a kind of automatic process, like banks and huge companies, mainframes will insert thousands of jobs. So there's a process or another program running. It can perform this automatically, taking the next job once one job finishes. So operating system creates a new process and runs the next job from the input queue. Okay. So creating a new process is useful when the work to be done can be formulated in terms of several related but otherwise independent interacting processes. So they are related, they are similar ones, but independent from one another, different job. So you create different process. A new process is created by having an existing process. New process is created by having an existing process. Execute the process creation system call. So in order to create a new process, you have to call this command, process creation system call. Okay, so that's about process creation, how to start the process. So you have described 4 situations where you need to create process. And the next is how to terminate, stop. Perhaps you have watched that Terminator film. So the termination, how to stop. There are 4 types of process termination methods. Okay. So termination also 4 types. In 2 different types called voluntary and involuntary. This is something you have to learn. Okay. How to terminate voluntary or involuntary. So voluntary means you know the meaning, volunteer. Sometimes you do volunteer jobs. Willingly you are doing. In our case, not paid, for example. Voluntary service like that. Involuntary is not like that. Okay, the opposite. So when the process terminates on its own, then it is voluntary. I get the meaning. No? When the process terminates on its own, it is known as voluntary. But sometimes they are not stopping like that. We have to kill them, yeah, or stop them. If the process terminates due to a different reason, then it is involuntary. Okay, I hope you got the meaning. If you don't understand, you can ask questions. Huh? Okay, so let's discuss one by one. One by one means termination. We have 4 types again. Right? There are 4 types of process termination. So first one is the normal exit. So normal exit is voluntary. So one process just perform its function and stop it. So process will terminate because they have done their work. Right? For example, when a compiler has compiled the given program. So when you write source code, you compile. So once it has finished, compiler process, it's done. The compiler executes a system call to tell the operating system that it is finished. So computer, you have to tell everything. Okay, it is not an intelligent one. So compiler should send a system call to the operating system telling that my job is finished. But it's a voluntary one. Right? This call is exit. Sometimes your source codes you use the term exit. Right? So it's a voluntary. So exit in Unix. And Windows, they use the code exit process. Okay. So this will be a voluntary termination. What is the normal exit is a voluntary termination. Then sometimes we get error exit. It is also voluntary. This process termination occurs when the process discovers a critical error. Sometimes our source code error checking commands. If this condition happens, we can exit like that. Okay. So if it discovers a critical error, you can use. For example, if the user types the command cc foo.c. Does anyone knows what's the meaning of cc command? If anyone use Linux or Unix, probably, or command prompt to execute, what is cc? Anyone? Hmm? Compile. Right? So if you write a C code, you save it as .c, right? So cc, this is the file name, foo.c, your source code in language C. So when you want to compile it, we give cc and the file name. So this command to compile the program name, file name is a C program. Extension is C. foo.c. And what will happen then compiler is checking your files in the stored files, no directory. And if compiler find no such file exists, what will happen? Now you are giving this command, but probably your actual program is full.c. Let's say your file is full.c, but mistakenly you did a mistake when typing the name. So compiler is searching for this file, it is not available in the directory. Then you have to exit, right? So compiler simply exits the program because they cannot find it. So this is known as error exit. So it's again voluntary exit. Okay, that's what you have to remember, because our computer, it's a normal process. If you cannot find the file not in the directory you have mentioned, then it's a normal error exit. Therefore it is known as again voluntary, right? Then this one, fatal error. This is involuntary exits. Right? When you compile, you sometimes see this kind of errors. No, so it's like you are forcing it. For example, error caused by the process will terminate the process. So error caused by the process, it terminates all process. Okay. Due to error, it can kill your whole executing program, for example. So that kind of error is not voluntary one, right? It's involuntary. It is not normal exit. So this is often due to the bug in the program. Right? So when you write program, there can be bugs, errors. Maybe missed close bracket, or something. Sometimes you create bugs. So in some systems such as Unix, the process can tell the operating system that it wishes to handle certain errors itself. So operating system can handle certain errors by itself. Operating system can handle, it wishes to handle certain errors itself. In which case, the process is signaled instead of terminated when one of the errors occurs. So how Unix doing this is the terminate command. In Windows, you try again. So it is involuntary. Okay. Then killed by another process. So one process can kill another process. The process executes a system call, telling the operating system to kill another process. Sometimes we, for example, if it is not responding, what do? You can go to task manager and kill it. So process executes the system call, telling the operating system to kill another. This time the process should have the authority to kill another process. The commands are kill and units, Windows called terminate process. Okay, is it clear up to now? So this is about process creation and process termination. So we have four types of process creation, four types of process termination. Okay, so some activities for you to understand more. Describe process creation and termination methods in your own words. Once you have finished your own writing, you can check. Answers are not here, but I can give you answers you need, but you have to do it by yourself. Because this kind of questions I may ask in your exam, right? To check whether you have understood the concepts. Okay. Here up to now, I hope you understand these things. Then another important one is something called process models. In the following section, we are going to discuss two process models. Okay. So one is, so this is a kind of model. So we have two states. This is one state, this is another state, right? State of a process is not running or running. So our process can be in not running state or running state. Right? So processes which exist are known. Let's see. Two states model. Okay, it has two states. One is running state, another one is not running state. So running state means process is running. Dispatcher of the operating system will select new process to run. Dispatcher process is running. Dispatcher of the operating system will select a new process to run. Not running means simply process is not running. So you can take one from not running state to running state. It is known as dispatch. So while you are running a program, if we pause it, it's very common when you run audio program, there's a pause button. No? So if you click pause, it is no longer running, right? Then you have to put into the waiting or not running state. Okay. So when you pause the running process, it will change its state running to not running. So when this is resources are available, you can take one uh, temporary stopped process from the queue and dispatch it. Dispatch it to another one on the queue. Right? So enter and exit. Enter means new processes are coming, and once it is terminated, you can exit it. Okay. So model is diagramic. As a diagram, you can put these things. So two states, running and not running, and you can put arrows how to change from one state to another. The processes which exist are known by the operating system, and they are waiting other process not running. Okay. Process not running means processes which exist are known by the operating system, and they are waiting to run. So this is known as two-state process model. Why two states? We have one here, another one here, two states. These circles are states. So since we have two circles, it's two-state process model. And yeah, I forgot to mention these are the reference books won by William Stellings. Right? Probably this is available in the library, and also you can download it. And it's freely available. If you cannot download, I also can give you the soft copy. You can try to get that from the internet. Huh? Operating system Implements and Design Principles. This is the name of the book written by William Stellings. Another book I'm using is Tannenbaum. Let's see, you have seen that. Stellings and Tannenbaum, those are the two famous books, operating system books, and referring this. Can you see this book name?
Yes, sir. Modern operating system.
Yeah, this is the modern operating systems. Uh, I got the copy, third edition, but the latest editions. But normally freely available are old editions. It's okay for us to learn basic concepts. Okay. So modern operating systems by Andrew Tannenbaum is the second book I'm referring. So like I have downloaded, you can download this. Chapter 1 I downloaded. And these are for your references. Modern operating systems, right? And don't worry about the edition, you can get any edition. Okay. Let's see whether we can. Okay. So this is one book. You can see on the chat. The other one is The one actually is already there and we can using as okay, share screen. Can you see it now? The operating systems. And design principles. So William Steins.
We have not clear user.
Hmm?
We have not clear heard user.
Can you see the screen now, PowerPoint screen?
Yes, sir.
Yes, sir.
Yes, there's a name called Operating Systems, Internals and Design Principles. 6E means 6th edition by William Stellings. Okay, let's see whether I can put it into the chat. Yes, now you can see now. Let's go back to PDF. Right. Okay, this is the two process model. Now the processes which exist are known by operating system and waiting for an opportunity to execute. They are not running state. So from time to time, the current running process will be terminated, right? Current running process will be terminated time to time, and when you terminate, and dispatcher will select another process to run. So dispatcher, these are again programs or commands you have put in your operating system. So dispatcher can select another one to run in state. Okay, so dispatcher will select another process to run. Therefore, the former process moves the running state to not running state. Okay, former process which was in running and move to here. Another one from here will come here. Okay, not running state, and one of the other process move to running state. So all the not running processes will enter into a queue, and from the queue, the dispatcher will select the next process to run. So not running is a kind of queue. So dispatcher can take one by one when resources are available to run. Okay, I hope it is clear. It's a simple model. Then there's another one called file state model. Why file state? It has 5 different states. So running state already there, dispatcher taken from the ready queue. Because sometimes we have processes blocked. Blocked means you can't run it until some event occurs. So it is waiting for an event, right? Therefore, we have different state called blocked state. So once the event occurs, but if the let's say CPU is not available to run, we put that into ready queue. If a process finish, we can release it and exit. New coming processes, we can keep a queue and add it to ready state. Okay. So this is known as 5-state process model. So according to the 2-state process model, the dispatcher could not just select the process at the oldest end of the queue. Rather, the dispatcher would have to scan the entire queue and have to select the process which is not blocked and has been in the queue for a long time. So earlier model, you don't know whether it is blocked or ready. So dispatcher has to, there's a power failure this side, so
I thought.
so just try using a mobile. Uh, Alright, let me share. I can see the screen, right?
Yes, sir.
Okay. So that's about 5 state process model. So you should learn these 2 process models. They are not complex if you understand. Any problems here understanding? It's I think not that difficult. Right? New state admit process is there to enter new process to ready state. And block one, it is waiting for event, and once event is certain, it can move to ready state. And again, dispatch can here here there are 2 rows you have to understand. Earlier, only one-sided arrow, right? But this model, both ways there are arrows. Why is that? Can anyone explain? This timeout process will explain that. So when you running a process on a CPU, right? So we have sometimes hundreds of processes running at a given time. So we have to share the CPU time sharing. So once one process allocated time is up, time slot, so it is timeout. Then you have to pause it for a while until it get a chance again. So it is not a waiting for event, but not available of the processing time. So we can directly put that into ready key. Okay. So that is why this timeout arrow again going from running to ready state. Yeah, that's the only difference here in this diagram. Others are clear, no? So this is known as 5-state process model. So you may have to explain 1 or 2 models. Okay. Last year also there was a question, I think. Now you should know how to draw a process diagram and explain each of these states, and also these are known as transitions. Transit from one state to another state. So admit is a transition. Dispatch is a transition. So what are the 5 states? We have running state, ready state, block state, new, and the exit. Okay. These states. So you can read them. I have already explained them. Then you should be able to explain it. So at the initial stage, the process is in a new state, incoming process, right? New state. At that time, the operating system has performed necessary actions to create the process. So we have learned to create process, right? So when admitting, you have to create a process and still not execute, not committed to execute the process. You admitting. When the process obtains necessary resources to execute, when it is ready to execute, you can transfer it to new state to ready state. Right? That is the admit. If the dispatcher selects the process to run within the main memory using the CPU, so for example, dispatcher selects the process to run from the main memory using the CPU. The status of the process will change from ready to running. That means from here to here. Main memory is ready, then when you dispatch to CPU, it is become running state, change to running state. Running process will change its state to ready when it comes to the end of its time slot. So if a given time slot of the CPU is finished, you have to put back to ready state. Okay, to execute and hand over the processor to another process. So when your time slot is finished, you allow processor means CPU, to select another process. But you have to wait in the ready state until you get another task. But if the executing process is waiting for an event to occur, it cannot execute until it gets a result from another event. Maybe waiting for your user input for your password, for example. So until the user enter the password, you block. The process is blocked, right? Then the process state will change from running to blocked. Okay. Finally, when the process is terminated, naturally, that means voluntary termination. By abort due to an unrecoverable error, maybe another. It will stop involuntarily. The process states will change from running to exit. In these diagrams, you will be able to see the following transitions in 5-state process model from ready to running or running to ready. These are the arrows actually. Like ready to running, that is the dispatcher. Running to ready, timeout, or running to exit, release. So these are known as transitions. Okay. So you should be able to explain each arrow or the transition, how changing from one state to another. You should be able to describe when it change running to block. Running process requesting some action which it must wait. For example, waiting for a user input. Like that, you should be able to explain each transition of the diagram. Right? Lock to ready, new to ready, running to exit. The process is finished running and so describe how two-state process model differ from five-state process model. Now you should be able to use your own words. What is the difference between two-state process model and five-state process model? Right. So we have discussed the completed lesson 4. Lesson first we discussed how processes are created and terminated. So you should know process creation and termination. And then we describe two process model in detail. And two and actually 5 process models in detail. So next lesson you will learn process hierarchy and process status. Do you have any questions? This is not here. Is it clear about processes, or do you have any questions to ask? So two-state process model and five-state process model. And now we are talking about inside the operation of a computer, right? So what operating system is supposed to do? So programming execution is the process. So we have to handle process. Right. Let's check whether you got the learning outcomes. You can describe different process models. Two-state model, five-state model. So different process creation methods, four types. different process termination methods, 4 types you should be able to describe. Okay. Do you have any questions? Or we can stop the lecture for today. I hope it is clear. Anyone got questions or any comments? How's your experience of learning online? Is it better than lecture rooms?
No, actually, the real lectures are better than online lectures.
Yes. Actually, I find difficulty of explaining certain things. Like using whiteboard and so on, you can explain a lot. We have also got whiteboard, but difficult to use. Unlike the classroom monitors. And yeah, the other thing, if I see your faces, I know whether you understood or not. Huh? You have the advantage. I cannot see whether you are sleeping or not. So you to learn. It's your responsibility. Uh, but anyway, my lectures, if you have any problems, you can ask any time. Share this, right? So I hope all of you have submitted your first assignment. Next, if you have still difficulties, let me know. Probably I can give you a chance to upload. Okay. Right. Then we'll stop there. Okay. Thank you.
Okay, sir. Thank you very much, sir.
Thank you, sir.